We know that the data in computers gets stored in the terms of bits. Now the question is, can we shift these bits to the left or right? The answer is yes. We can do it by using the left shift or right shift operators. Hello everyone, I am Gyan and you are watching the second session of Java and Wave, variables, data types and operators. In this video we will learn about the bitwise left shift operator in Java. We have a 32-bit integer variable a which contains 69 in it. And we want to shift bits of this variable a two places left. The operation starts from the least significant bit. The least significant bit gets shifted two places left. And that's how the rest of bits also get shifted to the two places left. That's how we have shifted all bits to the two places left. Finally, it comes terms of the two most significant bits. If we shift second most significant bit two places left, then it will go out of the 32-bit range. And same thing happens with the most significant bit. If a bit is going out of the 32-bit range, then it will be discarded. Similarly, the most significant bit also going out of the 32-bit range, and that bit also has been discarded. Now you see here, there are two vacant places at the least significant side. So fill the zeros in the vacant places of the least significant bits. The result is 276 in integer, 276 in 32 bits. Here we are applying the left shift operator in a program. We have an integer variable a which contains 32-bit binary of the 69. And here we are applying the left shift operator on the variable. The output in integer is 276 and that 276 is going to be stored in the integer variable b. And finally we are printing the integer variable b. Let me compile and execute this program. Open leftshift.java and this is the program. Save and compile it. Java C leftshift.java. Compiles fine and then run it. Java left shift. It runs fine and printing 276 as expected. But the scenario is little different when we are working with the byte variable. Here we have byte variable a which contains 69 in it and we have to do an operation a left shift b. Like other binary operators, the left shift operator also converts both operands to the maximum of integer type of a and type of b, that is integer. So first both a and 2 gets converted into the integer. 2 is by default a 32-bit integer literal and a which is a byte variable gets converted to integer like this. Then we start shifting from the least significant side. We start shifting like this. We shifted two places left. The next bit also got shifted two places left. And finally we did same for all the bits. Finally we came to the second most significant bit and we cannot accommodate this second most significant bit in the 32-bit range after shifting. That's how the second most significant bit gets discarded. And same thing happens with the most significant bit. We cannot accommodate it in the 32-bit range and that's how the most significant bit also gets discarded. Again there are two vacant places at the least significant sides, so accommodate two zeros there. That's how when we left shift the 8-bit byte variable which contains 69 two places left, then it will result 276 in integer. It will result 276 in 32 bits. The return value of the 276 is of type maximum of integer, type of a and type of b, that is integer. Here b denotes the 2. If we want the result in byte, then we must have to typecast the result of overall operation. After typecasting the overall operation, the 8 least significant bits will be taken out. And the decimal equivalent of this 8 least significant bit is 20. In this program we have a byte variable a which contains 69 in it. And then after we are shifting the byte variable a two places left. This operation results in integer. And that integer value is going to be stored in the integer variable b. And finally we are printing the integer variable b. Let me apply this program in a code. Open leftshift.java. Here we have two integer variables. Make the data type of the variable a from integer to byte. Write here byte. Now we have byte variable a which contains 69. We are doing an operation a left shift 2 on the byte variable a which returns integer and that integer is going to be stored in the integer variable b. Let me save and compile it. Java C leftshift.java. Compiles fine and then run it. Java left shift. It runs fine and printing 276. Let me update this code. Open leftshift.java. Make the data type of b byte instead of integer. Write here byte. Now this program will not compile because the result of this operation is an integer and we need an integer variable to store the integer. We cannot store an integer in the byte variable. Let me try to compile it and see what the compiler is saying. Java C left shift.java. Compiler says incompatible types, possible lossy conversion from integer to byte. The output of this operation is integer, which we are trying to store in the byte variable b. Now let's typecast the operation. Typecast here and make the result as byte. Write here byte. And then finally we will store this byte data in the byte variable b. Let me save and compile it. Java C left shift.java. Compiles fine and then run it. Java left shift. It runs fine and printing 20. How it's printing 20 we have already seen. Like the byte variable, we can do the left shift operation on the character variable also. Write here character. And store the character literal in the character variable a. I want to store it in the integer variable b. Write here int. Remove this typecasting. So finally we are left shifting the character variable a and storing it in the integer variable b. Let's save and compile this program. Java C left shift.java. Compiles fine and then run it. Java left shift. It runs fine and printing 260. We can store whatever returned by the left shift operator in the character variable. Write here char. We are storing the output of the left shift operator in the character variable b. But the output of the left shift operator is of type integer, not character. So first typecast it to the character. Typecast it to the character. Write here char. And now we are printing the character variable b. It will print the character whose Unicode is 260. Save and compile it. Java C left shift.java. Compiles fine and then run it. Java left shift. It runs fine and printing a, I don't know what we can say this character, but it is printing something different from the conventional a. In this case we have an integer variable a which contains -1 in it. You know that when we make all the bits of a signed integer 1, then it results in -1 in decimal. So all the 32 bits of the variable a are 1s. We have to left shift the a by 2. The operation starts from the least significant bit and that has been shifted 2 places left. That's how all the bits has been shifted 2 places left. Finally we have to shift the second most significant bit 2 places left, but after shifting it 2 places left it will go outside the range of the 32 bit. And that's how the second most significant bit will be discarded from result. The same thing happens with the most significant bit also. It also gone outside the range of the 32 bit and has been discarded. We have again 2 vacancies at the least significant side and we have added 2 zeros here. The decimal equivalent of this binary is -4. In this program a is the variable of type integer which contains -1 in it and we are applying the left shift operation on the a. The bits of a has been left shifted by the 2 places. And it results in integer. That integer is going to be stored in the integer variable b, and finally we are printing the integer variable b which outputs -4. Let me execute this program. Vi left shift.java. We have the same program. Let me save and compile it. Java C left shift.java. It compiles fine and then run it. Java left shift. It runs fine and printing -4. In this case we have a byte variable a which contains -1 in it. And we are left shifting the a by 2 places. Like previous, -1 first gets converted into the 32 bit, but at this time by adding the 24 extra 1s instead of 24 extra zeros. Now the operation starts. The least significant bit left shifted 2 places. The other bits are also left shifted 2 places. Second most significant bit and most significant bit has been discarded. And the vacant area at the least significant side has been filled by the 2 zeros. If we typecast the result of operation by byte, then the 8 least significant bits will be taken out. And that will also result -4. So it does not matter a is integer or byte, the result is -4. So let us try to execute this code practically. Open leftshift.java. Make it byte. Write here byte. Now we have a byte variable a which contains -1. We are left shifting the variable a by 2 places. The result of this left shift operation is integer and that integer we are going to store in the integer variable b. And finally we are printing the integer variable b. Save and compile it. Java C left shift.java. Compiles fine and then run it. Java left shift. It runs fine and printing -4. Change the type of variable b from integer to byte and see what the compiler is saying. Try to compile it. Java C left shift.java. Compiler says an error. Incompatible types, possible lossy conversion from integer to byte. Now let me typecast the result of operation. Write here byte in between the opening and closing a small bracket. Write here byte. We do not have to typecast only A, we have to typecast the result of overall operation. So write the operation in between the opening and closing a small bracket. Now save and compile it. Java C left shift.java. Compiles fine and then run it. Java left shift. It runs fine and printing -4. The bitwise shift operators cannot work on the boolean data type. Means it's illogical to shift a true or false. Let me try to left shift the true or false. Write here true. I want to shift it by 2. Let me check what the compiler is saying. Java C left shift.java. Compiler says bad operand type for the binary operation left shift. Also, we cannot use the floating point numbers as the various operands of left shift operator. Let me write here 5.2. I am trying to left shift the 5.2 2 places left. Let me try to compile it. Java C left shift.java. Compiler throws an error, bad operand types for the binary operation left shift. We cannot use the double or float as the operands of the left shift operator. This is a task for you to apply the discussed bitwise operators on the negative operands. Suppose we have a byte variable a which contains -5, we have another byte variable b which contains -6, and we have an integer variable c. Here we are applying various bitwise operators on a and b. In all these cases, the 8-bit binaries of -5 and -6 first gets converted into the 32-bit binaries of -5 and -6, and then the operation occurs on those 32-bit binaries. So this is a task for you to figure out all these operations as we did it earlier. Another task for you is that apply these operations on the long, short and character variables or literals. That's all for this video guys. Don't forget to like and share this video, subscribe this channel if you are new, and leave your valuable comments in the comment section below. Thanks for watching. See you in the next video.